I'm Alex, and this is my adventure into coding and machine learning.
While I've worked on various projects using Python, like simulating shadows, exploring fractals, and collecting my battery performance data, my largest project was with forest fire prediction. This began in 10th grade when I taught myself coding, starting with a basic numerical simulation. The initial version was pretty ineffective, so I switched to machine learning. First, I collected data using the Global Fire Atlas of 2012 to 2016 and selected the largest 100 fires per year. After months of developing techniques with the Google Earth Engine Python API, I gathered over 80,000 forest fire instances across hundreds of hours of downloading. Data included burn area, wind conditions, rain, and forest data across 2 consecutive days. These were stored as NumPy arrays. Using this large dataset, I developed a simple fully convolutional network, or FCN, to train with 2 days of data at a time. It works by applying spatial activation functions called kernels to input data, learning the optimal patterns for prediction. The results were promising. The model predicted areas similar to how a human might, suggesting burn areas near the first day's data. It achieved an impressive 97% accuracy based on a binary cross-entropy loss function. However, this was misleading. The visual predictions were often inaccurate. The issue stemmed from unreliable data. Second-day burns frequently looked random, making accurate prediction impossible. To address this data quality issue, I expanded the FCN to include 3 days of prior data for predictions. This required transitioning to convolutional 3D models, which process 3D inputs. To do this, I launched a CUDA-accelerated Amazon Web Service server, but quickly found this model had poor performance and trainability for this purpose. After further research, I tried a ton of different variations: dice loss functions, custom loss functions, learning rate schedulers, random cropping and rotation of input data, and I even coded my own convolutional LSTM model, which combines recurrent network features with convolutional layers. Ultimately, I couldn't proceed due to the inherent limitations of the data. Intervention in forest fires couldn't be accounted for, regardless of the model. While my network achieved high predictive accuracy, this project was just the starting point of my machine learning exploration. It was an amazing learning experience, and I continue to use the skills I learned in all my other projects.